All right, so for homework, I had asked you to do practice 10 to the evens. So we can quickly go through this. Should have been pretty easy for us. Let's get started here. So problem number 2. It's just asking us to write it in another form. So 27 to the 4/3 is equal to 81. Well, in log form, we would say log base 27. 27 to the 4/3 power is equal to 81. So you can see I use that crisscross method. Problem number 4, it's saying again use a translation property. Log to the 3/2 of square root of 6/3. Don't let that is equal to -1/2. So don't let that confuse you. Using the translation property, we're just going to write 3/2 to the -1/2 power is equal to the square root of 6/3. For number 6, it's asking us to evaluate log base 10 of 0.0001. We don't know what that is, so from the notes I told you to put x. Using the translation property, 10 to the x is equal to 0.0001, or 10 to the x power. This would be 1 over, let's see, 1, 2, 3, 4. 1 over 10,000, which is the same thing as 1 over 10 to the -4. If you take the reciprocal property, and then we could see that the powers would be equal. X would equal 4. Problem number 8, it says log base 1/3 of 27. Make it equal to x. So 1/3 to the x power is equal to 27. 1/3 is the same thing as 3 to the -1st. 27 is 3 to the 3rd. So negative x would be 3, or x is -3. Number 10, log base 8 of 4. We don't know what that is. So we could say that this is 8 to the x power is equal to 4. Well, 8 is really 2 to the 3rd. 4 is 2 to the 2nd. So 3x would equal 2. X would be 2/3. Number 12, we're looking to solve them. So the log base y of 16 is equal to -4. So translation property, y to the -4th is equal to 16. Well, one thing that we could do here is we could, we could write this as 1 over y to the 4th equals 16 over 1, and then just cross multiply. It's a proportion. So we get 1 times 1 is equal to 16 times y to the 4th. You divide both sides by 16. Get y to the 4th equals 1 over 16, and the 4th root would give us y is equal to 1/2. Now, some of the more skilled, or some of the, the better memory students that are watching this recognize that you have an even, odd, so you do need plus or minus. That turns into absolute value. But remember what we said, the base can have a negative base. That's why the answer is just positive 1/2. Remember the property. Anytime you take an even root of anything to an even power and you get an odd exponent, you need absolute value. Right? So that's been coming up all year. Number 14 says log base 7 of n is equal to -1/2. Translation property, 7 to the -1/2 power is equal to n. So n would equal 1 over the square root of 7. It's going to be 1 over 7 to the 1/2, and you guys know 1/2 is the second root of 7 to the 1st. If you multiply by the square root of 7 over square root of 7, you'd get that n is equal to root 7 over 7. It's rationalizing. You don't want the radical in the denominator. Number 16, log base x of the third root of 9 is equal to 1/6. Translation property, x to the 1/6 is equal to the cubed root of 9. One thing we could do is we want x to the first power. So we could raise both sides to the 6th power using the properties of exponents. 1/6 times 6 is just 1. And this was really 9 to the 1/3 to the 6th power. Power to a power we multiply. 1/3 times 6 is 2. 9 to the 2nd is 81. Number 18, we have log base 7 of 8x plus 20 is equal to log base 7 of x plus 6. Property of equality says if the logs, one log is equal to the same log with the same base, you can cancel those. So 8x plus 20 would equal x plus 6. Getting everything on the same side, you'd have 7x is equal to negative 14. X would be negative 2. Just want to make sure that our arguments are both positive, which they are. Number 20, we have log base 12 of x minus 9 is equal to the log base 12 of 3x minus 13. Same bases, so x minus 9 would be 3x minus 13. Taylor-Swift's favorite number. Getting all the x's on the same side, negative 2x is equal to, let's see here, 4. Negative 4. You'd get that x is 2. The problem is that argument, if you put 2 in, you get a negative log, so we actually don't have a solution for this. No solution is the solution. And then our last problem, number 22, another good Taylor Swift song. Log base 4 of x squared plus 6 is equal to the log base 4 of 5x. Same bases of those logs, those cancel. X squared plus 6 equals 5x. Let's get, it's a polynomial, so let's get all the terms on one side so we can make it equal to 0. Factoring, we get x and x, 6 and 1. So x would equal, let me see, did I do that right? Negative 6. And 4 plus 6 equals 4 or 5x. Oh, you know what? When I brought the 5x over, I should have kept this as positive 6. So I made a little mistake there. Let's fix this here. If we have to get positive 6, then we could use negative 3 and negative 2. So x would be 3 and x is 2. Just checking if we plug both of them in, they would work over here, and they would work over there as well. All right, so stay tuned for the next lesson.